Let's take a look at all the operations of functions. This is straightforward. So for example, r times x of x is just r of x times s of x. R minus s of x is just r of x minus s of x. And r plus s of 4 is r of 4 plus s of 4. So to do these problems, we know how to take care of multiplication, addition, and subtraction of expressions. So this is very similar. This is similar. So we have r of x times s of x, which is multiplication. So you have the product. And then you just FOIL. So we ended up with 2x squared plus 6x plus 12x plus 36. So what I have when I combine like terms, we ended up with 2x squared plus 18x plus 36. For subtraction, we have r of x minus s of x, which is 6 plus x plus 6 minus 2x plus 6, which is negative x. And then for the last one, I think it's easier for you to evaluate before you add. So I would just evaluate first. R of 4 is going to be 4 plus 6, which is 10. And S of 4 is 2 times 4 plus 6. So you want to plug it in right here. For this one, you plug it in right here. So what I have for this one is 14. And when you add them up, R of 4 plus S of 4, you just add them up, which is 24. All right, moving on to number 5. So h of x and g of x is defined as follow. Now, we want to find the division. So like I said, I think it's easier if you evaluate first. So let's do h of negative 2 divided by g of negative 2. So h of negative 2, we have negative 2 plus 1. And on the bottom, I have negative 2 times negative 2 minus 5. So what I have is negative 8 times negative 1. So I have 4 minus 5 is negative 1. So we ended up with negative 8. All right, so for part B, they're asking you for the values that are not in the domain. Every time we have fraction, we don't want 0 on the bottom. So the values that are not in the domain, that's when the bottom, which is g. So h of x right here, and then g of x is negative 2x minus 5. So when negative 2x minus 5 equal to 0, that's when we have the problem. So negative 2x minus 5 equal to 0 gives you x equals to negative 5/2. You do not want this point. Otherwise, if you have that point, or you have that values, the function is going to be undefined because you have 0 on the bottom. All right, so every time you talk about fraction, you have to be careful with 0 in the denominator. Now, suppose that the function f and g are defined as follows. We want to find the division. So straightforward, like I said. So we just have f of x divided by g of x. So in this case, we have 2 over x plus 4 over 9 over x. So don't forget, when you divide, you multiply by the reciprocal. Okay, so I'm just going to simplify it. So 2x, I'm not going to distribute because we have to find the domain. So the domain is everything but the value would make the bottom equal to 0. Okay, so so in this case, what do we have? Okay, so you see from our original problem right here, you do not want 0. Okay, 0 would make the function undefined. For the new function, you do not want -4, because if you have -4, this is going to become 0 and it's going to be undefined. So you have to look at the new function and you have to look at the function before we simplify. So we're going to have to include both. So the domain, we want to toss out those two values. So the domain is going to be from -infinity to -4. And this is how you exclude -4. And we also want to exclude 0. So I'm going to have to do this. And -4. Okay, so if I want to graph, it would be from -infinity, but then at 4 we have to keep it open. So we have two holes at -4 and at 0. So we include everything but -4 and 0. Okay, moving on to number 7. So number 7, we have two different functions, and like again, we're gonna find the addition and the multiplication. So addition, we just simply add, right? G of x Okay, so clearly we can't really simplify. So when you can't simplify, you're just gonna keep it that way. All right, now for this particular function right here, you do not want 0 on the bottom, right? In this case, there's no way we're going to get 0 on the bottom, because let's say if I have a 0 here, I still have 3. So 0 times 2 is 0 plus 3 is still 3. So no matter what, I'm going to get some number other than 0 right here. Now, one more thing about the bad values is the square root function. The square root function doesn't take negative number. So you're going to have to take care of this portion of the function. So how do we do that? We want to keep that function positive. So we're going to keep that function positive. We can include 0. So when we solve it, we ended up with 4/3. So for the domain of this function, we have to start at 4/3 when you go to infinity, because if we go anything below 4/3, anything less than 4/3, we're gonna end up with a negative number inside the square root, and we don't want that. All right, for multiplication, we just simply multiply. So if I have f of x times g of x, and I just multiply them together, and that's it. That's the answer. I can't, like I said, I can't really simplify anything. Now, what would be the domain for this one? Same thing. We do not want negative number for the square root function. So the domain is going to be exactly the same. So domain, go from 4/3 to infinity. Okay, moving on to number 8. So for number 8, this is something different. So this one right here, you taking care of the composite. So we need to find Q of R of 3. So what you want to do is you want to evaluate R of 3 first. So I'm going to do R of 3, which is 2, 3 squared plus 1. Which is 19. Now, instead of writing Q of R of 3, I'm going to write Q of 19. Okay, so we're going to use the Q function now, which is negative 19 plus 2, which is negative 17. And that's Q of R of 3. All right, that's what we call composite. And that's what number 9 is all about. So what you have right here is Q compose R, which is Q of R of 4. And then Q compose R compose Q, which is R of Q of 4. Okay, so we're going to do the exact same thing. So first, I'm going to try R of 4. I'm going to try R of 4. So R of 4 gives me 4 squared minus 1, which is 15. So instead of writing Q of R of 4, I'm going to write Q of 15. And then we evaluate. So it's going to be negative 2 times 15 minus 2, which is negative 30 minus 2 is negative 32. All right, now for Q of R, I'm going to write down here. So Q of R, Q of 4 gives me negative 2 times 4 minus 2, which is negative 8 minus 2, which is negative 10. So instead of writing R of Q of 4, I'm going to write R of negative 10 because Q of 4 is negative 10. So now we're going to use the function R. So we have negative 10 squared minus 1, which is 99. Okay. All right, moving on to number 10. Number 10, you don't have the values, so they're just simply asking you for the compositions G of G and H of H. So what is G of G, which is G of X? H of X is H of X. All right, so how do we do it? We're gonna take, let's try the first one. So G of X, G of X. So we're gonna take G of X and you plug it in G of X. So it looks like this. 5 over, that's gonna be G of X, which is 5 over X. What's that? That's a quotient. So we multiply by the reciprocal, which is X. Now I'm going to do the same thing for H. So H of X. So what I have is I have to put h of x in here, and h of x is x squared minus 5. So what we have is x squared minus 5, and then I have to square it and then minus 5. Okay, so we want to FOIL minus 5. So in the end, we have x to the 4th minus 10x squared plus 20. All right, moving on to number 11. So number 11, once again, we have the composite. And the composite in this case is going to be g of h of x. So I'm going to have to take h of x and I plug it in right here for g. So let's do that. So we have the square root 2, but instead of x, we have x minus 5 plus 20. Now, we're going to have to simplify that because we can. So 2x minus 10 plus 20. So it's going to be 2x plus 10. Once again, we have square root function, so you do not want this one to be negative. So I'm going to set it to be greater than or equal to 0 and solve for it. So we have x greater or equal to negative 5. So the domain, we start at negative 5 and we go to infinity.